I'm a chartered civil engineer. I specialized in geotechnical engineering, which is soil mechanics, foundations, and basically the behavior of soils. These are the foundations for all structures that we use in the civil environment. What you will also find with a lot of construction projects and just the health and safety records for buildings in general is that a lot of the construction drawings are done at a time when you may still be bidding for work, for example. And basically, the foundation information, piling, earth-retaining structures, etc., are not formally finalized in the drawings that you'll get, which is annoying for me. So I decided to look deeper into what are the mechanics of soils. I worked on some mining projects, so the site that you see in the photographs was from a number of years ago where I'd be, say, surveying the slope stability for the open pit mine, looking at what levels and topography we're getting at. There would also be wastewater treatment sites and laboratory tests on the soils that were excavated and recovered. So that was a number of years ago, but more recently, on a live case, I went to an area which was an energy project. There was some excavation of natural soil that was going to be left as a natural slope for the project. In some areas, it held fast, it went as design does. In other areas, the soil failed. What's the difference? So I mentioned about laboratory tests, and these are undertaken to understand the soil mechanics and the properties of soils. So I proposed a academic research project for my doctorate, which was looking deeper into soil mechanics. So soils are comprised of solid particles, as well as air and water. And so in tests such as these, we're going to be looking at what is the proportion of the air, what's the proportion of the natural moisture, and what are the properties, whether it's a sand or a clay or a rock. These all behave differently. I was scheduling some ground investigations. As you can see in the plan, and if you know the City of London very well, there's a number of very tall, very old and protected buildings with extremely deep basements, or maybe deep piles if they're skyscrapers. Also, we have a lot of transportation links that are underground. For example, if you can make out that east and west, we have the Circle Line, Hammersmith and City Line, District Line. This is running a very shallow level, as you appreciate if you've used the underground. Anyway, this particular site was chosen as it is undisturbed ground that we can sink, not we, but the engineers can sink the tunnel boring machine and any heavy plant and equipment they need to form the new structures and tunnels. And therefore, there were certain exploration points that were designated. This would be the plan of where the shaft was. And what we're looking at is this balance of soil, water, and air. For example, to dig a deep excavation, you need to protect all the adjacent structures and make sure that there's no ground settlement analysis and disturbance. And so this is all by doing the investigations to look at what's the soil behavior like. I actually returned to my mining engineering roots by getting involved with the International Maritime Organization when we're reviewing research projects and drafting regulations for bulk cargoes, specifically mineral ores. Because going back to when I said there's a solid, liquid, and air void element of soils or excavated ground of any type, what you might get is a solid material like a clay or iron ore or coal, and it may behave like a liquid if the moisture content is too great.